Okay, so go ahead and pause the video and copy in what I have written. So we're going to be talking about slant asymptotes. When we have slant asymptotes, this tells us there will be no horizontal asymptotes. So whenever you have a slant, that tells you no horizontal asymptote. So what we're going to do, we're going to be using synthetic division to figure out what that line is going to be. Because it's a diagonal line, it's going to be in the form of y equals mx plus b. So if you remember that from like maybe ninth grade, m is going to represent slope and b is your y-intercept. So in this sense, this one had a y-intercept at 1, and it looks like it has a slope of 1. So this line would have been y equals x. We're going to figure out how to find that y equals mx plus b, and we're going to do that by either using synthetic or long division to divide p of x by q of x. So we're going to, and when we do this, we're going to ignore the remainder. Don't worry about the remainder. I'm going to do the first one. Actually, I'm going to do number 2, and you're going to do number 1. So we're going to set up synthetic division. Remember when you do synthetic, it's like x minus 3 is a 0, so you set it equal to 0. You get x equals 3. So we've got 3 on the outside, a 3, a negative 7, and a 0. Bring down your 3. 3 times 3 is 9. Add those together, we get 2. 3 times 2 is 6. And we get a remainder of 6, but you don't care about that. So we're going to rewrite this. It's going to be 1 less than before. And we get y equals 3x plus 2. This would be our slant asymptote. Go ahead and pause the video and do this one on your own. You know you're doing it right if you got y equals x plus 5 as your slant asymptote. For these next ones, they're a little bit trickier because we can't do synthetic division, but we're going to do long division instead. Okay. So our first step is to figure out how do we get this into this. So we're going to have it be a 2x. 2x times 3x is 6x squared. That's perfect because now they match. 2x times 2 is 4x. We're going to subtract this out. These go away. This gives us a 0x. Bring down your negative 11. To get 3x into that 0x, we have to multiply it by 0. 0 times 3x is 0x. 0 times 2 is 2. Subtract them out, we get negative 13 as our remainder, but remember we're going to ignore our remainder. So our answer is up here. Our slant asymptote is y equal 2x plus 0, or you can just say y equals 2x. Next one. So we've got, we can't do synthetic division, my bad. So we're going to put x squared plus 2x minus 3 on the outside, and x cubed plus 3x squared plus 0x plus 0. And let's solve through. Let's get this one to look like that, so we need to multiply by x. Minus the entire thing. Don't be a dodo, subtract the whole thing. 3x squared minus 2x squared is just x squared. 0x minus a negative 3x would become plus 3x. Bring down that 0. Now we're focusing on how to make this look like that. We have to multiply it by 1. And so we get x squared plus 2x minus 3. Subtract the entire thing. Those go away. And we get x 0 minus a negative 3 is b plus 3. This is our remainder, but we don't really care about the remainder. We only care about what we are going to have. So this tells us that our slant asymptote would be y equals x plus 1. Okay, now that we know how to find slant asymptotes, let's move on to a couple of practice problems. First one, x squared minus 9. So I'm going to rewrite this and do synthetic division. This is like 1, 0, negative 9. This is like x plus 0, so we're going to put a 0 right here. 1, 0 times 1 is 0. Oops. 0 plus 0 is 0. 0 times 0 is 0, and then the minus 9. That's my remainder. I don't care about my remainder, but I care about this stuff. So this is like y equals 1x plus 0, or just y equals x. So I'm going to take that and put it as my slant asymptote. Remember, we're not going to have any horizontal asymptotes, so you can ignore that one. And then we're going to solve the rest of it how we did on our last handout. I'm going to start by putting my slant asymptote on the graph. So it's going to have, because it says like plus 0, we have a y-intercept at 0, 0, and then a slope of 1. Okay, so there's my slant asymptote. Let's do our vertical asymptote. Our vertical asymptote is whatever can't work on the bottom, so x can't be 0. So we're going to say x equals 0. Normally when we do our asymptotes, they're dotted lines. So I normally just go back with my eraser and just kind of go back and make it a dotted line. And let's do the rest. So in order to find a x-intercept, we're going to put in a 0 for our y. So this would be 0 equals x squared minus 9 over x. We don't really care about the denominator because we multiply it on both sides and it zeroes out. 0 equals x squared minus 9. 9 equals x squared. X equals plus or minus 3 when we take the square root of both sides. So we've got an x-intercept at 3, 0 and at negative 3, 0. I'm not going to have any y-intercepts because there's an asymptote on the y-axis. So I'm going to say none. So my graph, let's see, what color do I want to do it in? Do it in this one. It's going to approach these asymptotes real close like. Just like that. Let's talk about domain and range. My domain for this one is going to be x can be everything except, oops, I missed a step. My asymptote, which is at 0. My range, it looks like range could be anything, so I'll put all real numbers. There are no holes for this one. Okay, let's do the next set. Let's hop down to this one. A good idea is to simplify as far as you possibly can. So this could be rewritten as x squared plus 3x minus 4, x plus 2, x minus 1. We can even simplify this one further. Which would be x minus 1 x plus 3. Nope, x plus 4, excuse me. And now I see that there is something that's going to cancel out. I've got this x minus 1 on top and bottom. This tells me that there's going to be a hole at x equals 1. But we have to write it as a coordinate, so it's going to be 1 comma something. This rewritten is x plus 4 over x plus 2. So if I plug a 1 into everywhere I see an x, this is 1 times 1 plus 4 over 1 plus 2, or 5/3. So I'm going to say there's a hole at 1 comma 5/3, or you can write it as 1 and 2/3, which is 1.66. So I'm going to go to my graph right now and just go ahead and put that there is a hole happening there. 1 and 1.66. So we've got something right here. There's an open circle. Okay, let's do our slant asymptote. I'm going to do it with, let's see, long division, this piece. I can do it actually with this one, because this one is actually x squared plus 4x over x plus 2. So watch this. Ooh. We can do it as 1, 4, 0, negative 2. 1, negative 2, 2, negative 4, negative 4. Which we don't care about the remainder. We just care about this piece. So my slant asymptote is going to be y equals 1x plus 2, or just x plus 2. And so if we put this on my graph, we have a y-intercept of 2 and a slope of 1. Alright, there's my slant asymptote. Put a dotted line in there. This is a boundary where the graph cannot cross. I'm not going to have a horizontal asymptote, but I can look at the denominator and see that right here, I can't have x be negative 2, so I'm going to say at x equals negative 2, we have a vertical asymptote. I don't know if you guys can see that or not, but there's a asymptote going on right here. So let's do our x and y intercepts. I know that my y-intercept is going to occur when x equals 0. So looking at my graph or my functions, if I set this equal to 0, I get 0 equals x squared plus 4x, or 0 equals x times x plus 4, do ZPP, x equals 0, or x equals negative 4. Ooh, I totally did that wrong. I solved for the x-intercept, so that I plugged in 0 for x, 0 for y, excuse me, and we got 0, 0, and negative 4, 0. So we got a dot right there, and 1 right here. The y-intercept is if we put in 0 for x. So, like on this one, it would be 0 times 0 plus 4 over 0 plus 2. It wouldn't matter because it would be 0 over 2, which is just 0. I also see that they both have a point at 0, 0. So that's how I know that. Okay, so I'm going to draw my sketch, jump over that hole. It's approaching your asymptotes, and you leave that as is. So for my domain, x cannot hit my asymptote, so x is not equal to -2, and it can't hit my hole, which is at 1. My range, it looks like it goes up and down for all values, so I'm just going to put all real numbers. Nope, I don't have much battery left on my iPad. Let's see if I can make it. Next one. I recommend simplifying whenever you can. So this one becomes x squared minus 1, or x times x plus 1, x minus 1, because we have a difference of squares. And then this one is x minus 1. It's actually a perfect square. X minus 1 times x minus 1. So if I rewrite this, check this out. We've got some cancellations going on. If I've got cancellations, that means I've got a hole. So I've got a hole at 1 comma something. If I were to rewrite this, my simplified version is x plus 1 and x minus 1. Or I can write it as x squared plus x over x minus 1. If I plug in a 1, I get 1 squared plus 1 over 1 minus 1, which this one won't work. So at 2 over 0, it's undefined anyway, so it doesn't matter. It basically says that this hole lands on an asymptote, which means it's unnecessary, so you're going to put none. Okay, let's do our slant asymptote. So I'm going to take this equation and do synthetic division. 1, 1, 1, 0. 1, 1, 2, 2, 2. It's my remainder. I don't care about it. So I'm going to look at this piece and write my slant asymptote, which is going to be y equals 1x plus 2, or just x plus 2. Let's put that on my graph. So we've got a y-intercept of 2 and a slope of 1. So there's your slant asymptote. I'm going to have no horizontal asymptote. Let's look at vertical asymptotes. So looking at the bottom, what can x not be? X can't be 1. So my vertical asymptote is right here. And let's do our x and y intercepts. Let's do y-intercept first. That's when you put in a 0 for x. So if I put in a 0 into that, you get 0 squared plus 0 over 0 minus 1, which is 0 divided by -1, or just 0. Then I'll do my x-intercepts. This is when y equals 0. And so you're going to set this equation equal to 0. 0 equals, actually, I'm not even going to do that one. I'm going to do this one. So I can multiply the denominator on both sides, and I still get 0 equals x times x plus 1. And so if I do ZPP, I got 0 equals x, or x equals -1. And I put it on my graph, so I've got 1 right here. And that's it. So when I draw this graph, something cool is going to happen. It comes up, and then it bounces down. And this one, the same thing. do my range. Range is a little funky, so let's talk tomorrow. But the domain, it looks like it's going to hit everything except for my asymptote, which tells you x can be anything except for 1. And there's that. Let's do this last one. Start by simplifying as far as possible. So this one can be written as x plus 6, x minus 2, and this one will be an x plus 2, x minus 2. Right off the bat, I can see that these are going to cancel each other out. So now I've got x times x plus 6 over an x plus 2. Or if you wanted to write it as one value, x squared plus 6x over x plus 2. So since I had those items cancel out, it tells me I have holes. So I've got holes at x equals 2. I'll have to put into the function 2 comma something. So we're going to plug a 2 in for x. I'm going to use this one. So we get 2 squared plus 6 times 2 over 2 plus 2. 4 plus 12 over 4, 16 over 4, we get 4. So right off the bat, 2, 4, we have a hole. Let's do our slant asymptote with synthetic division. So we've got this as our slant asymptote, which is going to be y equals 1x plus 4, or just y equals x plus 4. We have a y-intercept at positive 4. And a slope of 1. Let's talk about our vertical asymptotes. I'm going to use, well, either of them work, so I'll do the bottom. X can't be negative 2. We're not going to have any horizontal asymptotes. Y-intercept. What happens when you put a 0 in for x? If I put a 0 in for x here, I get 0 times 0 plus 6 over 0 plus 2. We get a 0 over 2, which is just 0. My x-intercept is saying what happens when you put a 0 in for y. So we are going to get 0 equals x plus 6. I don't have to put it in with the bottom, because if I multiply the bottom on both sides, they're going to cancel out anyway. Straight into ZPP, 0 equals x, or x equals negative 6. So there's enough points for me to draw a quick sketch approaching my asymptotes. And I'm done. So it looks like my domain, x can be almost anything. It just can't be my asymptote at negative 2, or it can't be the hole at positive 2.